Example 8, identifying combined vertical and horizontal shifts. We want to write a formula for the graph shown in figure 11, which is a transformation of a toolkit square root function. So, the graph of the toolkit function, f of x equals the square root of x, starts at the origin. So this graph has been shifted 1 unit to the right, and then we can see up 2 units. So if it starts at the origin, we move to the right and then up 2. Now, in function notation, we could write that as the following. Using the formula for the square root function, we can write it as the following. We have f of x, which is equal to the square root of x. So this was our function to start with. The green was our toolkit function at 0, 0. And then if we shift to the right 1 unit, that means we need to subtract 1 to the input. That would give us 1, 0. So in red, we'd have g of x, which is equal to the square root of x minus 1. And now we need to then shift it up 2 units. So that means we need to add 2 to the outside of this function, meaning the output. So h of x is going to equal the square root of x minus 1 plus 2. Now note that this transformation has changed the domain and range of the function. So this new graph has a domain of 1, including 1, to infinity, and the range starts at 2, and that goes to infinity. And again, if we want to take a look at this as a graph on Desmos, okay, if we have the square root of x, right, that's what happens. So this was our original toolkit function, okay, starting at 0, 0. And then if we take the square root of x and then subtract 1, then we can see that it moves to the right 1 unit. So using Desmos is going to be a good thing for you to do during these transformations. And then if we take the square root of x minus 1, and then we're going to add 2, then that gives us the function that we started with.